All right, lesson 7.2, scientific notation. Scientific notation is a way to write really large or really small numbers, like those used in science. For example, the mass of the sun. If you could find the mass of the sun or calculate it, it would be 2 with 30 zeros kilograms. Take a long time to write that. It takes up a lot of paper. The mass of a proton is a very small number, 0.26 zeros, and then 1673 kilograms. Again, a very small number, takes a lot of space, takes a lot of time to write. So scientific notation will simplify this. It makes it easier, quicker, takes up less room. The correct form for any number in scientific notation is one number, then the decimal point, then the rest of the numbers. And this is going to be, this first number here is going to be a number that's not 0. So 1 through 9. You're then going to times it by 10 to some power. And what that exponent does is tell you here how many places to move the decimal and what direction it moves. Does it move to the left or to the right? So let's look at a couple examples. Now the opposite of scientific notation is standard notation. That's the big long number with all the zeros in it. Again, we look at this exponent here to tell us how many places we move the decimal. Every time we times something by 10, it moves the decimal over one space. So this, we're timesing it by 10 5 times, which means my decimal is going to move over 5 times. So my decimal will now be there. I fill in these extra spaces with zeros. So my final answer is 701,000. Another example, 2.6 times 10 to the 4th. Should give that one a try. Take this current decimal right here, and we're moving it over 4 spaces. Every time we times by 10, the decimal moves over to the right one. Now it's timesing by 10 4 times. See what you get. Fill those spaces in with zeros. And our final answer is 26,000. Negative exponents work the same way. Remember, negative exponents, this is from our lesson yesterday, this really means this. It really means we're dividing by 10 5 times, and every time we divide by 10, we're actually going to move the decimal the other direction. We're going to move it left. So currently, right now, this decimal is right here, 9, right in that spot. And I'm going to move the decimal over 3 spaces, 1, 2, 3. My new decimal is going to go right here. I fill in these gaps with zeros, but don't leave this as your final answer. Always put a leading 0 in front of your decimal point. That one there. It just makes your answer clearer, and it definitively tells you where the decimal point is. It doesn't get lost or forgotten about. So please put that leading 0 in front, and that's your answer in standard form. The last 3 we'll do is write numbers in scientific notation. So this is the other way. We're going to use our correct form. Remember, we're going to have one number, then the decimal, then the rest, times 10 to some power. So currently, we have our decimal right here. But I know proper scientific notation tells me that the decimal should go here. I should have 1 then the decimal. So again, I have one number in front of the decimal and then all the rest. So to get from this back to my original problem, right, I have to take this decimal and it would have to move 2 spaces to the right. So my exponent is 2, positive, because this decimal has to move 2 spaces to the right to get back to the original problem. Oops. So 2 would be our final answer. Next one. Proper placement of my decimal is between the 4 and the 8. So in proper scientific notation, this is going to be 4.8 times 10 to something. So if it were 4.8, to get back to this original number here, where my decimal is right here, to get back there, if it were 4.8, I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces, and I just moved to the right. So my exponent would be a 10, positive, because I want it to move to the right. Final problem. Again, my decimal is right here currently, but proper scientific notation tells me it has to be 9.7 times 10 to some power. And to get from 9.7 back to my original decimal, 1, 2, 3, 4, 5, 6, 7, I had to move this 7 spaces. This decimal would have to move 7 spaces to the left, making my exponent a -7. Negative because it has to move to the left. We'll finish up with the remainder of the problems tomorrow, first thing in class.